Okay, good morning students. Welcome to the session. Now today's class we discussed about direct memory access. In earlier class we discussed about modes of transfer. Okay, it is a subpart of the modes of the transfer. In modes of the transfer means it transfers the information between the I/O devices and memory. Okay, with the help of the CPU. Okay, we have three types of modes of transfer. First one is programmed I/O. Second one interrupt initiated I/O. Third one is direct memory access. What is the work done in the programmed I/O? The data that can be transferred from input devices to the memory. Okay, it has the CPU is whether to check the data that is coming from I/O devices is available or not. Okay, here the loop will be repeated again and again. That's why here the CPU utilization is not efficient manner. Okay, that's why in programmed I/O that consisting of the CPU is in idle state, that is in the waiting state. Okay, whatever the information that is coming from the I/O devices to the memory, okay, the data is coming or not, that can be checked with the help of flag bit. Okay, flag bit is 1, then the data register contains some information of data. If flag bit is 0, it does not contain any data. Here, the loop will be repeated again and again. That's why the problem will be occur. The CPU is in idle state and waiting state. Okay, that's why we have go to the interrupt initiated I/O. Okay, in interrupt initiated I/O, okay, like this, the information is transferred from I/O devices to the memory. Okay, here also, okay, it transfer the information from input devices to memory. Okay, here the problem will be occurred, the data that can be transferred from input to the memory, but which device is generating the interrupt signal does not identify. Here the time taken also more in the interrupt initiated I/O also. Okay, here the data is transferred from the input devices to the memory. Okay, here also some delay is occurred. Okay, the memory is stored in the stack in interrupt initiated I/O. That's why the problem is some problem is arrived in the programmed I/O and interrupt initiated I/O, and then next approach is direct memory access. Okay, what is a direct memory access? Direct memory access means it transfers the information between the I/O devices. I/O devices means input and output devices to memory without any help of CPU. Okay, in programmed I/O and interrupt initiated I/O, they can transfer the information from input devices, output devices to memory with the help of CPU only. Okay, in this direct memory access, without intervention of the CPU, they can transfer the information from input output devices to the memory. Okay, that's why the major advantages of the direct memory access means in this direct memory access, we can control the data from input devices to the memory with the help of DMA controller. Direct memory access controller. With the help of direct memory access controller, we can store the information that is coming from the input output devices to the memory with the help of DMA controller. Okay, here the transferring of the data between the fast storage device such as magnetic disks and memory is often limited to speed of CPU. Here, direct memory access is more speed than the CPU. Okay, in computer we have CPU. CPU can perform several works at a time. It can perform multiple tasking. For DMA, it performs the data transfer from I/O devices to the memory. Okay, DMA control is a very faster than the CPU also. That's why it is a mainly advantages in the modes of transfer. That's why we call data memory access is a faster than the CPU. Because CPU has several works, it performs the multiple tasking. That's why we prefer the modes of the transfer between the DMA controller. With the help of DMA controller, we have to transfer input output devices to the memory. Okay, in removing the CPU from the path, letting the peripheral devices. Here peripheral devices means external parts of the computer. Input and output devices manage the memory buses directly. In direct memory access, we have some buses. Okay, some address register, data register, read-write operations and address selects we have to follow with the help of these peripherals. The path from the main memory to CPU and input output peripheral devices and DMA controller. This consisting of the data that can be transferred from these devices, input and output devices, CPU, RAM and data memory access controller. Okay, direct memory access transfer the block of data between the memory and peripheral devices. Okay, memory and peripheral devices. Here peripheral devices means IO devices. Data memory access that can be transfer the data between the peripheral devices to memory. Okay, or memory to peripheral devices. The unit that controls the activity of accessing memory directly is called DMA controller. This action is called, okay, what is the action? The memory and the data that can be transferred from memory to peripheral devices. That action is called nothing but direct memory access controller. That is nothing but we call it as shortly DMA controller. Okay. Okay, next coming to the block diagram of DMA controller. Here we have RAM, IO processor. IO processor means input output processor or peripheral devices. Next DMA controller and CPU. First let's take RAM. This is the RAM. Here it contains read operation, write operation, address and data. Here this is a peripheral devices input output processor. This is a DMA controller, that is a direct memory access controller. Next it is CPU. Okay, consisting of interrupt, bus request, bus grant, read operation, write operation, address and data. Okay, here also like that. This is interrupt, bus grant, bus request. Here we have DS and RS. Here address, select. Here the data that can be transferred from here, the direct memory access controller has BR. BR means bus request. That information is transferred to the CPU bus request. Here the BG also some content. Okay, that is transferred to the BG means bus grant. Okay, here the interrupt is available in direct memory access and controller. The information of DMA controller that is transferred to the CPU. Here we have in DMA controller has also we have read operation, write operation and address register and data register. Okay, that information is passed to all the devices. From read to read, write to write and address to address and data to data. Here we have the address register that is transferred to the address register and write operation, address register and also data register. Here IO request, here input output acknowledgement, ACK acknowledgement. Okay, this is the block diagram of direct memory access. Here we have to take 3-4 devices. RAM, input-output processor. Input-output processor is nothing but peripheral devices. This is a direct memory access controller, DMA controller. It consisting of interrupt. BG means bus grant. BR means bus request. Here we have to take two inputs, DS and RS. DS means DMA select. DS means DMA select, direct memory access select, and RS means register select. RS means register select. Okay, here BR means bus request. BG means bus grant. Okay, here from DMA controller interrupt to and CPU control interrupt can transfer the interrupt signal from DMA controller to CPU. Here, whatever the data that is coming from the RAM, that is stored in the IO processor. Okay, RAM is nothing but main memory. Okay, RAM is nothing but main memory. Here in RAM we have read operation, write operation, address and data. Okay, the data that is coming from RAM, that is stored in the IO processor. Okay, the IO processor transfer the information to the DMA controller with the IO request. Okay, after again DMA control transfer that accepts that information coming from the IO processor, that is transferred to the IO acknowledgement. Here the DMA controller can accept that information that is coming from the IO processor, then give the acknowledgement to the IO processor. Acknowledgement means the data that can be accessed that is coming from IO processor. Okay, here DMA controller has interrupt, BG, bus grant, bus request, DS and RS. This address select is connected to all read write operations and read write address data operations for every devices. Okay, here CPU, RAM and direct memory access controller consisting of read operation, write operation, address operation and data operation. What is the read operation? We can perform the read operations and can read that memory you can access with the help of read. Okay, whatever the modification that can be done with the help of write operation for every devices. What is the address? Address means always it holds the address of that memory or address of that devices that is holds in the address. Okay, the data is whatever the data of corresponding that device that is stored in the data registers. Okay, for every device we have read operation, write operation, address operation and data. Here also for RAM we have the read, write, address and data. Okay, here we have DS means direct memory select, DMA select, RS means register select. With the help of address select, we have to perform these both operations. With the help of address select, we can perform the DMA select and register select. Address select can be connected to all these three devices, CPU, RAM and DMA controller. Here, address select is connected to read, write, address and data operations. Okay. Here we have bus grant and bus request. Here we have to see that bus grant is equal to 1. It performs the DMA controller has connected with bus. With the help of bus, the DMA controller will be performed. If bus grant is equal to 1. If bus grant equal to 0, the CPU is connected with the help of bus. Okay, if bus grant is equal to 1, the DMA controller will be provided bus request to the DMA controller. If bus grant is equal to 0, the CPU can access that bus request. With the help of bus, the CPU can be access the memory. Okay, that is the meaning of BC is equal to 1 and BC is equal to 0. Here we have we have three types of registers that can be performed in the DMA controller. Okay, first one is address register. Second one is word count or word register, word count. Third one is control register. Control register. Here in direct memory access we have three types of register. First one is address register, second one word count, third one is control register. Okay, address register means here for example we have to take in RAM we have the memory like this. Okay, the memory contains some locations. Okay, consisting of some address 1000, 1001 and so on, 10,000 like that. Okay, consisting of some address. The address register specifies starting address of the memory. Okay, here the address register specifies starting address of memory. The address register specifies in memory that contains the starting address of the register. Okay, starting address of the memory. Here the starting address of the memory is 1000. Okay, that is identified with the help of address register. Here by this address register we have to increment it by 1 the address register. Okay, first of all we have to start with the 1000. Next 1001, 1002 like that we have to increment it from starting register in the address register. We have incremented by 1. Okay, we have to identify for address register, we have to identify the starting address and that is incremented by 1. Incremented by 1. Here means we have 10,000, next 10,001, 10,002, 10,003 like that the address register will be specified. Next coming to the word count. Okay, word count means we have to take this example. This is a memory consisting of 10 blocks in that memory. The content is 10 blocks. The word counting here is 10. In memory, the word count is 10. 10 means that for every word count, we have to decrement it by 1. Here the memory contains 10 word count. The word count for visiting the 1 by 1, the word count will be decremented by 1. The word count that can be decremented by 1. Okay, here in address register that identify the starting address of the memory and that is incremented by 1. For every visiting of that memory, for every block of that memory, we have to increment it by 1 in address register. In word count, in memory that contains the word count is 10. For a visiting of every word count, we can represent it as decremented by 1. Okay. For first one, we have to have 10. Word count is 10. Next, visiting the second memory contains, it is decremented by 1. That is 9. For next 8, 7, 6 like that, we have to decrement it by 1 in word count. Next, coming to the control register. It specifies the read and write operations of the every device. Okay, control register means it specifies the read and write operations of the every device. Okay, these are the 3 types of register that is available in the direct memory access. Okay, next coming to this diagram, CPU, RAM, IO processor, DMA control. Okay, the data that is coming from whatever the data that is stored in the main memory or RAM, that is placed to the IO processor. IO processor transfer the information to the direct memory access controller and the data is valid or accepted by the DMA controller and then transferred to the input output acknowledgement. Here read, write, address, register, address operations and data that can be connected to these 3 devices: CPU, RAM is nothing but main memory, and DMA controller. Here address select, okay, direct memory access select and register select is connected to address select. Okay, this is a diagram about the direct memory access. Here bus grant equal to 1. Bus grant means it is granted, it can be give the permission to the devices. If bus grant equal to 1, the DMA controller will accept the bus. Okay, then bus grant equal to 0, the CPU can accept the bus. Okay, here and also again we have 2 approaches for transferring the data. in direct memory access. That is first one is burst request. These are the two modes of the transfer in direct memory access. Second one is cycle steering. Cycle steering. Okay, these three are the register that is performed by direct memory access. And again we have two types of transferring of the data or modes. That is burst request or cycle steering. Okay, for example, you have to take this memory only. Okay, burst request means we have to execute these memory at a time. Okay, at a time total memory we have to follow, that is nothing but burst request. Okay, here this is a memory. Okay, the memory can be followed or executed at a time, that is nothing but burst request. And cycle steering means one by one. See, in serial manner it can be followed one by one, that is known as a cycle steering. That is a one method of the transferring of that memory at a time is known as a burst request, and cycle steering means one by one. Okay, the memory has some contents, one by one content. In serial manner, we have to transferring of the information or transferring of the data. This is nothing but cycle steering. These are the two modes of the transfer available in the direct memory access. Okay, this is nothing but the direct memory access. Okay, in modes of transfer, we have three categories of the data that can be transferred the input-output devices to the memory. First one is programmed I/O, interrupt initiated I/O, and direct memory access. Okay, first one, programmed I/O, it can transfer the information from I/O devices to the memory with the help of CPU. Here the problem is occurred, the CPU will be again repeated. We can whether the check the data is available in the data register or not. Here the problem is occurred that the CPU time is wasted and CPU is idle. Most of the time it is staying in waiting only. That's why you have to transfer the another approach, interrupt initiated I/O. In that also the problem is occurred which device is generating the interrupt signal. Okay, that is stored in the memory stack. The interrupt signal is generated with the help of interrupt that is stored in stack. Here also which device generating the interrupt signal, that is identified is very time taken is more. That can be identified with the help of interrupt initiated I/O, but it requires very time taken. That's why we have to follow the another approach, that is nothing but direct memory access. In direct memory access, it transfers the information from I/O devices to memory without intervention of CPU. Okay, here direct memory access only acts as a CPU, and also direct memory also is nothing but a processor. Okay, you can transfer the data from one device to another device. It performs like a processor. DMA, direct memory access, that performs like a processor. Okay, here we have transferring of the information from I/O devices to memory without intervention of the CPU. Only directly we can access with direct memory access controller only. Okay, this is a block diagram of direct memory access. In that we have 4 devices: RAM, I/O processor, DMA controller, and CPU. Okay, the data that is coming from the main memory or the RAM to the I/O processor, then I/O processor transfer the information to the DMA controller. Here DMA controller accepts the data, sends the acknowledgement to the I/O processor, and then transfer to the CPU. Okay, here interrupt that generated the interrupt signal. DR means bus request, bus grant. Okay, here read, write, address, data operation. Okay, address operation means that contains, that holds address of that device in address, and data means data, it can hold the address data of that device. Okay, here also direct memory also contains read, write, address and data register, and RAM also contains read, write, address and data register. Here the direct memory access consisting of 3 register: address register, word count, and control register. Address register is specify the starting address of the register, and every visiting of that register it is incremented by 1. In word count, For example, you have to take memory consisting of 10 words. Okay, for every visiting of the word count, it can be decremented by 1. Okay, here control register is nothing but read and write operations of every devices. These are the 3 registers that is provided in the direct memory access. Next, coming to the modes of transfer, that is a bus register, bus register request and also cycle steering. These are the another 2 types of modes of the transfer that is available in the direct memory access. Burst request means, okay, at a time it transfer the information to the another device. That is nothing but burst request. And cycle steering means it can be transferred one by one or serial manner, that is nothing but cycle steering. Okay, this is about direct memory access. In direct memory access, the bus grant is equal to 1. It performs the direct memory access controller with the help of bus. It accepts the bus request. And B is equal to 0, bus grant is equal to 0. It accesses the bus. It accesses the bus with the help of CPU. CPU accesses the bus request. This is about the direct memory access. Okay, thank you.